Action Fraction here to talk to you today about probability. Now, probability, especially simple probability, is the number of favorable outcomes, that's what you like, over the number of possible outcomes. That's how much you got. So what we're going to do is we're going to look at probability. Is it high probability, low probability, no probability? We'll see. Action Fraction.
Action Fraction.
Now, Action Fraction talking about probability. Now, probability is something that either is unlikely to happen, that means it won't happen, or that it is likely to happen, that means it will happen. So now I'm going to ask my friend student here, I'm going to say, what is the probability that I give an ice cream and that it melts in the sun?
100%.
Yes, that is correct. It's 100% this will melt in the sun. Now, what is the probability you will be able to eat this ice cream?
100%.
No, it is 0. Action Fraction.
Action Fraction.
Now that we've had an introduction into probability, I want to know, what is the probability that there's someone else who is as cool, who is as awesome, who is as bad as Action Fraction? Now I bet you're thinking there's nobody who's as bad as Action Fraction. Well, it is 100% probability there is someone as cool as Action Fraction. Introducing Reduced Action Fraction. Hit it.
Reduced.
Action Fraction.
Action Fraction.
Reduced.
Now, Action Fraction has a problem for you. Let's say Action Fraction wants to go on a trip. Let's say Action Fraction wants to take the school van. Reduced. What is the probability that I choose the yellow van?
50%.
50%! That's right. Now, reduced. What is the probability I choose the black van?
50%.
It is 50%. So tell me, reduced, am I more likely or am I less likely to pick the black or yellow van?
Equally likely.
I can't hear you, reduced. What?
Equally likely.
Equally likely. Action Fraction.
Action Fraction.
Reduced.
Reduces. Tell them how we say goodbye.
Reduces.
Action Fraction.
Reduced.
Hi, Mr. Billings here today to talk to you about simple probability. Simple probability. As you can see right here. Well, simple probability is basically trying to figure out how likely something is going to happen or not happen. So let's take a look. Let's create a little scale here and put likely. That means that it is likely to occur or probably going to occur. And then down here we'll put unlikely. Unlikely means that it probably won't occur. And then we're going to scale it all the way here on a little bar graph. Now I'm going to say that unlikely is 0 because if something is not going to happen, there would be like a 0% chance that it would happen. And if it's likely to happen all the time, then it's probably got a 100% chance of happening. And so everything we do with probability is going to be based between 0 and between 1 or 100%. Now, probability is all between 0 and 1. If we were to calculate 100%, 100% is equal to just 1. So everything we do is going to be between 0 and 1. So let's think about what I've got over here. I've got a coin. You can see this giant quarter. Now, if I flip this coin, let's talk about the options that I could get. It could either land on heads, or it could land on tails. Tails. So these are the two options that I have of what my quarter could land on. And if we look at percentage between 0% and 100%, if I were to flip this coin, I've got two different options. It could either land on heads or tails, so it'd pick one of these. And then there are two different options that it could land on. So I would have out of the two possibilities, heads and tails. So if I were to flip a coin, it's either going to be heads or tails. That's the one. Out of the two possible options, it could be heads or tails. Well, we know that half is 50%. And so 50% is the last part of simple probability. That's equally likely. Equally likely. If I flip this coin, I am just as likely to get heads as I am tails. There are only two options. I know I'm going to get one of those options, so therefore I'm going to have a 50% chance every time I flip this coin. Well, let's expand. Let's go a little bit deeper into this. What if I take this number cube, right? So we see this box here. I'm going to label it. We'll put a 1 on this side. We'll label this so it's got a 2 on this side. We know what most number cubes. I'll put 5 here. So let's pretend that this is the number cube. And I were to take this number cube and roll it. Well, how many sides do number cubes have? Each cube goes from 1 to 2 to 3, 4, 5, and 6. There are 6 sides to every cube. So if I roll this cube, this number cube, I have to think about what is the probability that I get a specific number. The first time I roll this, let's say I get a 1. Then we have to think about how many possible answers I could have gotten. Well, we know that there are 6 sides, so if I'm looking to try to get a 1, and there are 6 total sides, I can see that I've got a 1 out of 6 chance. Remember, with the coin, there were only 2 possibilities, heads or tails. Now we have 6 possibilities, the 1, the 2, the 3, the 4, the 5, and the 6. Every time you roll the number cube, you're only going to get one of those numbers, so you would have a 1/6 chance to get each one of these. 1/6. These are 1/6, 1/6, 1/6, 1/6. That's the probability to get just one of those numbers. You have a 1 out of 6 chance. If we were to look at that as a percent, it's about a 16.7% chance to get each one of those numbers. What if I expand on it though? What if I said, hey, what is the probability, and I'm going to use a capital P for this, and I'm going to say, what's the probability of rolling the number cube and getting an even number? What is the probability of rolling the number cube and getting an even number? So let's look at my number cube. First off, I can see, let's circle the even numbers I've got. I've got a 2, I've got a 4, and I've got a 6. So there are 3 possible even numbers that I could roll on this number cube. Now I'm going to take a look at how many total options I have on this number cube. 1, 2, 3, 4, 5, and 6. So there are 6 total options I could have, but 3 of them are what I'm looking for. 3 of them are even. Well, I see then that 3 out of the 6 options will be even. That reduces to 1/2. And hey, look, if I were to categorize this as likely, unlikely, or equally likely, I would say that the probability of rolling an even number on a number cube is equally likely as rolling an odd number, because that would be 3 to 3.
Oh, you know what? I just got a fun idea. I'm going to erase this real quick. Let's think about this. Let's go and try to do another probability now. Let's see what the probability would be on a number cube if we try to find the probability of rolling a prime number. What's the probability of rolling a prime number on a number cube? First off, a prime number, just to remind you, is a number that only has two factors, 1 and itself. So let's circle the prime numbers over here on our side. Can you find them before I do? Oh, so we see that 2, 3, and 5 are all prime numbers. And then we see how many total numbers we have. Again, it's 6. So I can reduce this down. Oh, look, we have equally likely chance of getting a prime number as well as a different number. Now, how many of you possibly came in and said 1 is a prime number? I'm going to put 1 down. No, 1 is not a prime number. 1 is actually not a prime number, and it's not a composite because it only has one factor, itself. So 1 is in a special category all of its own. Good job on that. Let's take a look at one more example as we make it a little more complicated. Here I've got my coin now, but now I also have my number cube. So I'm going to try to figure out what the probability is of flipping a coin and rolling a number cube. Before I do that, let's talk about something called sample space. Sample space. Sample space is the possible answers that we can get in probability. So sample space is all of the different possibilities of numbers or of choices we could get if we flipped a coin and then rolled a dice. So let's think about it. If we flipped a coin, we've got a chance of getting two different options. Heads, which I'm going to use H for, and tails. If I flip a coin, those are the only two options I have. But now if I flip a coin and roll a number cube, I have to take into consideration the 6 different possibilities with a number cube. So if I could flip a coin and it could be heads, and then I could roll the number cube and it could be a 1. Or I could flip the coin and get heads, and then roll the number cube and get a 2. I could get heads and 3. I could get heads and 4. I could get heads and 5, or heads and 6. But then there's also the other flip of the coin. What if I got tails in 1? What if I got tails in 2? Tails in 3? Tails in 4? Tails in 5? And tails and a 6. This is the total sample space of the probability of flipping a coin and rolling a number cube. There are 12 possible answers. Heads and 1 through 6, and tails and 1 through 6. So I've got 12 different options for this probability experiment. So let's take a look. Let's try to find now that we've talked about those 12, let's give ourselves an exercise where we try to figure out what is the probability of getting heads and an even number. Heads and an even number. Well, let's think about the choices. So we know that with heads there are 6 different outcomes we could have. Heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. So how many of these are even? Well, the 2 is, the 4 is, and the 6 is. So 3 here. 3 out of my choices are all going to be good ones I like. But 3 out of 6? No. It'll actually be 3 out of 12 because there's also the tails options. Remember, tails 1, tails 2, tails 3, tails 4. None of these are the answers that I want because none of them are heads and even. So out of the 12 that I have, only 3 of them are the ones I want, which means I would have a 1 out of 4. It would be a 1 to 4 probability. We can change it to percent, which means I would have a 25% chance of flipping a coin and getting heads, and then rolling a number cube to get an even number. Don't forget to like this video and check back for more videos from Champion Schools.